Oxidation-reduction reactions are also called redox, for reduction and oxidation. Reactions containing oxygen as a reactant were heavily studied and documented. Historically, then, an oxidation reaction is a reaction of combining oxygen with another element. For example, magnesium was reacted with oxygen to give magnesium oxide. To describe this reaction, the metal is said to be oxidized. A reduction reaction, on the other hand, is a reaction of removing oxygen from a substance. For example, zinc 2 oxide reacts with hydrogen to produce zinc and water. To describe this reaction, zinc 2 oxide is said to be reduced. The modern approach to redox reaction is to assess the exchange of electrons between reactants. For example, the reaction between elemental magnesium metal and oxygen to give magnesium oxide, we would need to assign the oxidation state, which is also called the oxidation number. I will explain with examples how to do this later, but for now, we will call oxidation state a charge. So both elemental magnesium and elemental oxygen have no charge. With the ionic product, magnesium is +2 and oxygen is -2. To summarize, magnesium metal is elemental, is oxidized, and loses electrons. We can write this in an equation where magnesium goes to magnesium 2 plus 2 electrons. This is called a half reaction. For oxygen, that's elemental, it is reduced and it gains electrons. So 2 electrons plus a half O2 gives O2 minus. A redox reaction is a chemical reaction where the reactants participate in exchange of electrons. A half reaction is shown where electrons participate in the reaction. The sum of the half reaction gives the overall reaction. We'll come back to the reduction reaction with zinc 2 oxide and hydrogen gas later. Remember, a redox reaction is a chemical reaction where the reactants participate in exchange of electrons. The reactants do not necessarily need to involve a metal and oxygen. For example, chlorine reacts with iodide to produce chloride ions and iodine. For this reaction, what is oxidized and what is reduced? Remember, it is the reactants that exchange electrons. So I- is oxidized and chlorine is reduced. For the reaction between the chlorine and iodide, where chlorine was seen to be reduced and the iodide I- is oxidized, here's an explanation on the results. Often, it is easier to determine which reactant is oxidized and which is reduced by writing the half reaction. To do this, step 1 is to split the reaction up where only the chemical species are similar. Chlorine goes to 2 chloride ions. The 2 iodide goes to I2. The second step, balance the half reaction by adding the electrons, which are negative particles. So with the electrons on the reactant side, this would be a reduction half reaction, and with the electrons on the product side, this is an oxidation half reaction. An alternative method to determine which reactant is oxidized and which is reduced is to assess the exchange of electrons in these redox reactions. To do this, draw lines that match similar chemical species. Then, assess the exchange of electrons. Elemental form has no charge. The ionic form has a -1 charge in this example. So chlorine, going to the chloride ion, it goes from a 0 charge to a -1 times 2, because there are 2 chlorides, for a net gain of 2 electrons. Because it gains electrons, this is a reduction. For the reactant iodide, I-, going to iodine, I2, it goes from a -1 times 2, because there are 2 iodides, to a 0 charge. There is a net loss of 2 electrons, and a loss of electrons is oxidation. How to make this assessment on complex molecules, we'll need to determine how to assign oxidation numbers.